Today we will take the topic called alcohols. Alcohols is a part of the topic of the compounds containing OH. You can call them as a hydroxy compounds. Hydroxy compounds. In this we have three parts. The R containing OH, that is a alkyl group containing OH group compounds, you may call it as a alcohols, where alkyl group can be a methyl, ethyl, and 1 degree, 2 degree, 3 degree, and so on. Second type will be the aromatic case, when aromatic OH containing compounds are phenols. When OH directly attached to an aromatic system like benzene, naphthalene, and so on, they are called phenols. Whereas if an alcohol instead of hydrogen, if you have some alkyl group, they are derived products of the alcohols, we are taking as a ethers, ROR we are taking as a ethers. So all these three will have some interrelated properties, and a comparison, preparations, and all that will be some common. The procedures are there, and related topics comparison we can take up. Now at the first we will take up the regarding the alcohols, its preparations and the properties we will see. So let us take preparations of alcohols. The first method will be by hydrolyzing the alkyl halides. Hydrolysis of alkyl halides, RX. General equation you may show like RX when treated with the OH minus, you will get the ROH. An example you may take a methyl chloride, for example, on reaction with sodium hydroxide, an aqueous solution, just boil for some time. The OH will replace the Cl, and this happens to be a substitution with a nucleophilic reaction where OH is replacing and you are getting a methanol. And the Na and the Cl will become into the byproduct NaCl. Like this ethyl alcohol and propyl alcohol, all corresponding alkyl halides, there is no exception, all can be prepared like this. But the reactivity order may be noted. A tertiary alkyl halides may be giving a faster reaction than a 2 degree than the 1 degree. If you go to the mechanism side, the tertiary follows a SN1 mechanism and prefer this reaction. And before that you can also note like a benzyl halide, that is an aromatic attached carbon if halogens are there. These are much more reactive, followed by allyl type of the halides. They come under the second, then comes only this type. Afterwards the halogens, that is vinyl type, will be the next. And then lastly you have a aromatic system containing halogens, hydrolysis of the aromatic. This is very, very tough. So the first benzyl halides and the vinyl, the allyl halides. Allyl means the double bond next carbon halogen. If a double bond, on the double bond we have, these are called vinyl type. These are all aryl. Here we have a benzyl, first variety is benzyl. Then second variety allyl. Then this 3 degree, 2 degree, 1 degree alkyl halides, they come under the alkyl halides. Then vinyl and the aryl. These two goes through the SN1 very much readily because their carbocations are resonance stabilized. That's why the benzyl halides undergo very fast hydrolysis. And vinyl and the aryl have a common property, less reactivity, that is a nucleophile attacking on the unsaturated carbon, which is electron rich, it is tough. There will be a resonance stability for these compounds, reactivity is less. The X and C happens to be a double bond in the resonance structure, so therefore replacement of the X is tough. However, in the aromatic case, if there are any groups like withdrawing groups at ortho and para and ortho, then this type of the aryl also will become slightly better hydrolyzing property. But all the alkyl halides give the corresponding type of the alcohol. This is the first and the simplest, most easiest method also. Let us go to the second method, the preparation of the alcohols by reduction of aldehydes and ketones. Reduction of a carbonyl compound that can be subdivided into the aldehydes reduction and ketones reduction. Both give the corresponding carbonyl compounds. Any aldehyde starting from formaldehyde you can take and reduce it. The simplest reduction is using hydrogen and a catalyst like nickel. So, it is an addition reaction, each side 1 H is added and the compound becomes into the 1 degree alcohol. You can make a note, all aldehydes will give 1 degree alcohols. All aldehydes and reduction gives the 1 degree alcohols. 1 degree alcohols are prepared by the reduction of the aldehydes. Similar case, if ketones are taken, ketones also with the same reagent will give the 2 degree alcohol. So, in this method we have a drawback, a 3 degree alcohols cannot be prepared using this type of the reduction of carbonyl compound. No carbonyl compound will give 3 degree alcohol under this type of the circumstances. So, now let us go to the third method. This is hydration of alcohols, hydration of alkenes. The simplest alkene, if you take ethylene, add HOH. However, only water on ethylene has no action, but if you have a catalyst like a concentrated sulfuric acid, a few drops is enough, actually a few drops is enough. A few drops of sulfuric acid. So, you may write this concentrated sulfuric acid plus water is nothing but the dilute sulfuric acid. At room temperature itself, that is not necessary to heat also. Now, the HOH adds, it is a electrophilic addition reaction with the electrophile from the proton from sulfuric acid add. This is all the mechanism, but finally what comes is a ethyl alcohol comes. So, here a substituted alkenes like let us say one alkyl containing alkene, if you take it follows a rule called Markovnikov rule. The rule says that the minus party goes where hydrogen is less, that means OH goes inside and the compound will be like this. If propene is taken, 2 propanol will be the normal. Under these conditions it follows Markovnikov rule. The product may be one type of, that is 1 degree type of alcohols also can be prepared using the B2H6, that is hydrogen diborane followed by the treatment with the hydrogen peroxide. If you add then you may get the other type of the product, that is CH2CHOH. Here H minus will be added and the B plus is added according to the Markovnikov rule only, but the product formed like this, intermediate will be like this. H is added and the B is added. So, H is added to the center and the B is added to the terminal. So, a trialkyl borane comes as an in between product, which on reaction with hydrogen peroxide will give the 1 degree type of alcohols are formed. This is 2 degree, this is Markovnikov rule. Here the product is formed anti-Markovnikov rule product, that is a propene. If you take 1 propanol will be the major product, will be the 1 propanol. You can apply anti-Markovnikov rule addition of the HX, HBr, hydrolysis also you may get this 1 degree type of the alcohols.